So as mentioned, I'm going to talk about secure space air-ground integrated networks. But I thought first, I'm expecting that many of you aren't familiar with Queen's and our cybersecurity research, so I thought I'd just begin with that. So I'm an academic at Queen's University in Belfast and doing my research out of our Cybersecurity Institute, which is the Centre for Secure Information Technologies. So we're the UK Innovation and Knowledge Centre for Cybersecurity. The other interesting aspect worth mentioning is our Cyber AI Hub, which probably links in a lot with the topic of the summit today. So the Cyber AI Hub was launched last year. It's a multi-million-pound project working with cybersecurity and AI companies. So essentially our model is within CSIT as an institute, we have sort of our academic research and we have an engineering team that helps to bring that research to reality. And we work very, very closely with companies. And as Liam mentioned this morning, obviously looking towards the impact of the research and the industry and the end user focus is really important for us and indeed for everybody in the research space. So with the Cyber AI Hub, we have specifically 8 companies that we're working, or 8 projects that we're working on. And I lead one of those on Open RAN security. But we work with a model where we have the academic team within CSIT, we have engineering from CSIT, and then we have engineering and leadership from the company. And we've got 8 of those, and the idea of these projects is to look at solutions either using machine learning and AI security within company technologies, or helping them to protect the use of ML and AI technologies. So that's that piece. In terms of the background to my work, I've been working for over 10 years really in software-defined networking security. So as we've also heard this morning about the sort of the use of security and the protections against security threats. So we've done the same thing with SDN security. We looked with, so software-defined networking being the idea of separating the data and control planes in the network, introducing programmability, and giving us a global network view. So you can benefit or hope to benefit network security using that global network view and the programmability, being able to iterate and individually address security solutions for the network. But also that separation introduces vulnerabilities as well on the interfaces as we separate out and distribute the elements of the network. So I see a lot of similarities actually in SDN and the frameworks we looked at introducing SDN, hierarchical and distributed frameworks, and the challenges associated to those, and the likes of our open radio access network and our distributed networks and wireless techniques today. So background in working on that. Also then, as you're more than familiar with machine learning and AI becoming ubiquitous, network security solutions also started using machine learning to accelerate and manage the large scale data that we have in those networks with the data, with the traffic. So machine learning based solutions, for example, intrusion detection systems, distributed denial of service systems, we started using the techniques to develop better systems. And then we also started looking at, well, this is a security system. We're supposed to be improving our network security, but we're potentially introducing challenges and vulnerabilities to that system by the use of machine learning. And Luis already mentioned the types of poisoning and evasion attacks that we can experience in that space. So we looked at developing the solutions. So for example, convolutional neural network based distributed denial of service system. So a solution using that, and then generating adversarial samples to improve the design and the training of that system itself. So a bit of work in that space. I mentioned the project, the Cyber AI project, that's focused on security, and we recently published on misconfiguration in ORAN, in the Open Radio Access Network, as a result of the impact of AI and ML use in that space, so for optimization, etc. The challenges might arise there. We've also done a bit of work as a Polymath Fellow at the Geneva Centre for Security Policy for a couple of years, and the idea there really being a couple of mentions, I think, in Madhu's introduction earlier about the legal, ethical and social implications of the use of these technologies, ethics and bias, for example, in our training of certain AI-based systems. So I've looked at the technical work that we do on network security and using AI and bringing that to the population, so the legal scholars and policymakers and government representatives, to try and raise awareness, okay, not just to adopt these solutions without considering what are the challenges to them, and including some of the technical challenges. So this isn't a technical solutions talk. I'm going to highlight just a few challenges and requirements and considerations that might be made as we're developing 6G and beyond. So SAGIN is how I would pronounce it. I don't know if that's right or wrong. Space Air Ground Integrated Network could be Space Air Ground C. Non-terrestrial network is a term used by 3GPP, aerial access network, etc. But the main element here is we're integrating all these layers of nodes and services, satellite communications, high-altitude platforms, unmanned aerial systems, and into our ground infrastructure for networking itself. And with that we get, as you can expect, massive scale and complexity. Also some intricacies that we haven't seen yet this morning, maybe later today, some discussion of as you go higher and go more global with the space system, for example, introducing low Earth orbit satellites, for example, you then talking about these astronomically distant networks, which changes the type of routing and networking required in that space. So also the distance that we experience with that, you're not going to be automatically or easily able to switch out nodes and devices on the fly. There's a cost to launching equipment and the cost to running it and maintaining it. And that has to be thought of both in advance and in terms of the potential, I suppose, an extension of what we already know as self-organizing networks, where machines interact amongst themselves and have swarm-type behavior to enable the communication. And a couple of other things I'll come on to in terms of resilience and trust as we go through this. So a couple of architectures just as a visualization of this. So I mentioned the layers. You've got the ground and maybe the sea network involved, and those platforms. Aircraft can be used to transfer data, operating as nodes within our network. We might have UAV or unmanned aerial system swarms. And then at that space level, we've got the low Earth orbit, medium, and out to geostationary orbit. In terms of space networks. You can see a lot of moving parts here. A second illustration similar on the left-hand side. And what we're looking at now is not necessarily the bidirectional, so an uplink and downlink communication to one or other satellite from the ground, but maybe hops between layers and different nodes that introduce a network. On the right-hand side, you've got an illustration of a swarm of UAVs, unmanned aerial vehicles, cooperating to provide coverage of the ground. And that, as you can imagine, I mentioned already, that sort of multi-party interaction and the dynamic nature of that. But you've also got their potential self-organization requirements and the use of, we see the use of machine learning heavily in that space to understand the behavior and make decisions about routes, for example. So some things I'm going to talk about: programmability, security, and intelligence. And something of a personal interest of my own is the sustainability as well. In terms of challenges, there's issues around frequency and spectrum allocation and usage with the increasing number of nodes across the network. You've also got, I mentioned already, the interlinkages between the networks and self-organization, but you've got ground stations and satellites to contend with. In terms of additional challenges beyond what we know sort of as even the low Earth orbit or the high altitude platforms, at the wider distance, you've got different coverage to consider. Obviously you get more coverage at a higher level or further distant from our Earth. But you also have mobility elements to contend with and difference in the propagation patterns there. So there's a lot of complexity introduced into these systems. But it is a vision of 6G that we will be able to leverage all of these elements to provide a more optimal routing and to enable, again, a point that Liam had made about the end user. This will all become invisible to the end user, but there's a lot of complexity layered into offering that seamless experience of delivering communication. So the other thing to consider then is, and I mentioned the software-defined network as an example, sort of leading into this 6G and Open RAN, different elements that we see of the communication design. the idea maybe of the satellites themselves offering a data plane, so becoming the nodes within the network at that level, and what we might need in terms of delivering that. So at that level, considering, I suppose, the differences in the communication patterns there, we have an introduction of delay-tolerant networking. So with mobility, with dynamic nature, and with different patterns of, from a physical layer perspective, even from transmission, we have longer latencies and intermittent connections. We can't always rely on delivery, so we don't use the same routing techniques that we can use on the ground. So for this, the bundle protocol was introduced by NASA, which manages packets and the transition of those in the space framework. There is a secure version of that called BPSec, offering authentication, integrity, and confidentiality. But there's little and limited exploration of that to date. So some of the work we're doing in the team is looking at how this might be applied and bringing some of the programmability and the security to bear on offering, for example, even if you think more closely to Earth, not necessarily looking towards communication with the moon or anything, if we think about disaster recovery scenarios, there's a similarity there in terms of the intermittent connectivity. And we can maybe use bundle type protocols and secure those to provide a better transmission path. Some of you may be familiar with, again, from STN, P4 is a programming language. The idea with P4 is that you can define, in fact, your own switch behavior, so routers and access points within our network. We can define how they want to transfer the traffic that they receive on the network. And I think that it's maybe a good candidate for the likes of a newer protocol like BP or any other delay-tolerant protocol that is conceived of that can be designed into these systems themselves. We can write this very simply to operate within the node. And then they could be deployed, as we say, in satellite environments or in any other environment. So we would have software-defined, delay-tolerant network nodes. To be determined, what level that operates, but again, something that we're looking at. But one of the challenges there is with the programmability, we get the flexibility, not only with being able to write our own behavior, our own network behavior, but then we also have the challenge. So in the ground networks, in our telco operators have been quite slow and loath to adopt SDN. It is in place quite predominantly now, but it's been a slow process because they couldn't determine or assure the behavior of the network. So talk about quality experience, but quality of service and the service level agreements that operators have to agree to and offer to their client base. When we have the ability to change behavior of the network on the fly, as happens in a programmable network, so we can offer reaction to events rather than defining the specific behavior. So under a certain circumstance, one action might happen, another circumstance, a separate action might happen. That offers an openness within the network that the behavior is not known necessarily at any point in time, and that's very troublesome for a network operator. So you can imagine if we do want to consider this for a space environment or even a more remote environment, we'll have to counter those challenges as well and that acceptability from it. In terms of security, there was some posters outside looking at about the idea of the beamforming. That can be a particular challenge or a particular security vulnerability in places. We've seen the use in the Ukraine, the LEO constellations, so the low Earth orbit mega constellations, the likes of Starlink have thousands of satellites in low Earth orbit offering connectivity across the globe. There's also Telesat in Canada, OneWeb across the UK with hundreds, and Amazon coming to proposing, they currently have several satellites up there, they're looking at thousands as well. So all of that can offer a great solution in terms of the connectivity in situations, disaster recovery situations, for example, or in this instance. But they're also vulnerable from the security perspective, and not only from a physical security, but it's not only at least from cyber, but from this physical security perspective, just from the interruption or the interference of signals can easily take out links within the network. Now there are solutions to some of these, but it does remain a challenge to be addressed. something to be considered. And the second part of that is actually the idea that there is a cost to deploying this equipment. So you have different launchers, certain people have access to the launch platforms, certain organizations are developing the actual CubeSats or smaller form factor satellites. So they will host payloads from other organizations, and parts of the components of that may be delivered by other organizations. They may communicate to different or ground facilities under the operation or the control of different organizations. So there's a lot of elements here from that supply perspective, from that security perspective. Consider who actually has responsibility for what, and are you comfortable with deploying, and how you protect your, if you're the owner or the deployer of the satellite, how you protect your system from the instances running on it, virtual instances or hardware running on it. And the NIST, the National Institute of Science and Technologies, are looking more closely into that space and offering recommendations around that. To date, from an intelligence perspective, machine learning and AI is used broadly. Mostly at the moment used for optimization purposes, so management, for example, radio resource allocation and those sort of bandwidth allocation exercises. Lisa's already given some detail and background about poisoning and evasion type attacks that can be experienced by machine learning techniques. But in this context, we can think about the security issue from the actual implementation. If you had, for example, the routing being determined by a machine learning algorithm based on the reliability of the links, so you're going to choose which way you transfer the network through your interconnected nodes, based on the reliability and the availability of specific links. That reliability is determined by weather conditions, let's say, and somebody can, malicious adversary can influence those data points and then thereby influence the whole distribution, the whole network routing capability. So it's a similar kind of behavior to a black hole attack that you might have, that we might be familiar with, people removing, offering a denial of service on our nodes, but it's scaled up by several tiers back in terms of where that vulnerability is introduced. So we need to think about the security there. And there is a sort of highlight here quite a lot of the services and use cases that are being considered and commercialized. So when we think about the security and the protection and any of the design of the satellite services and nodes to date, a lot of that has been done by government and military because they were large at geostationary orbit. We have the likes of the location, position and navigation. That is quite well secured and protected if it's done and designed and implemented by a single operator, such as a government. But commercial operations are now being introduced with this phenomenal number of LEO satellites for all sorts of different monitoring and tracking, video offering, and using different spaces, interesting things like real estate use cases, using visualization of the maps of what's going on, and then for more social activities as well. But basically any of that being interrupted, either spoofed, interfered with, or disrupted, means that you can't rely on the data. So it becomes more interesting from a commercial perspective as well, where there's not necessarily the same emphasis on security. Again, I'll refer back to Liam's presentation. Performance has always come first in design, and security is often left to the last minute, even though we keep trying over and over again to introduce it early. I'll skip over this from a time perspective. But just on to the last piece that I want to mention. So these are some illustrations of how busy the space around Earth is today. So different images of constellations of satellites being deployed. It's getting extremely congested, and although there is some effort and requirement in terms of deorbiting those satellites that you put up there, and mitigating any debris that comes down, or safely removing them from the sky, there's still a lot of work being proposed around disposable and attritable UAVs, for example. So there's a tension there between the idea of managing the space and keeping it clean, and our sustainability goals that we have from the UN, and then the idea of, okay, we can do something and we can do it quickly I've got this great little toy that will do this particular job. We have to manage sort of our attention to that. So there is a focus on secure sustainability, which I suppose my point here is to promote it more broadly, and to suggest that we might want to think about what we're producing and why, and the benefit of it overall. So just to summarise, the area that we're looking at is obviously the extension beyond just ground infrastructure and near Earth infrastructure out to wider global constellations. We've got physical and cybersecurity challenges there that we still need to do some work addressing, and potentially raise those now in the early stages and try and combat that focus that we always have on performance of our services. Programmability could be a potential, but we do have that tension of the autonomous behaviour and being able to assure that and introduce some new improvements on that. And then obviously we're going to be using machine learning and AI for optimization, and we definitely need to build in some of our solutions around securing that in advance of deployment of those. So thank you very much, and I'm happy to answer if there are any questions on that.